guys, welcome back to Algebra 1. We are going to review all of the inequalities that we went through yesterday. So I'm going to put 4 up here and we're going to go through and make sure that we understand how to solve them. Because today we're going to talk about absolute value inequalities, and absolute value inequalities apply what we learned yesterday about the compound inequalities. So I just want to make sure that everybody feels comfortable with that before we kind of go on to what we do. So let's take a minute, take about 10-15 minutes and go through these 4 questions here. So this first one is a negative 2x plus a 6 is greater than or equal to 3x minus 34. The second one here is 4 times x plus 2, which is less than a negative 1/2 times 4x minus a 4. So these two are just basic inequalities. They do not have any compounds, okay? This second one down here, or this third one, sorry, this is x plus 7 is less than or equal to a 2. Or, this is a compound, or there. And or x plus 17 all over 30 is greater than or equal to a 5. And then this one is a 30 is less than 2x plus a 1, which is less than a 13. Okay? Alright, so y'all try to do those 2 for me. Okay, so first one here, just a regular inequality. So we want to get the x by itself on the left. So first thing I need to do is to subtract my 3x. So when I subtract my 3x, I will have a negative 5x plus a 6, which is greater than or equal to a negative 34. I'm going to subtract my 6 on both sides here. So I'm going to have a negative 5x, which is greater than or equal to a negative 1040 there. Divide both sides by negative 5. So when I do that, I divided by negative 5, so it's going to flip the inequality sign around. And negative 40 divided by negative 5 is a positive 8. So x is going to be less than or equal to an 8. So at 8 we'll have a closed circle, and it's everything to the left here, less than or equal to. So this will be from negative infinity up to an 8. 8 will have a bracket around it, and infinity will have a parentheses. Alright, this one over here, multiply. So simplify here by multiplying. So 4 times x is a 4x. 4 times 2 is an 8. Is less than negative 1/2 times 4. So that'll be a negative 1/2 times a 4. So that's a negative 4 over 2, which is a negative 2x. Negative 1/2 times a negative, it's a positive. And that'll be a negative 1/2 times a negative 4. So that's also positive 2 then. Okay, I want to get the x on the left side here. So I am going to move my 2x over here, and I'm going to cross that inequality. So I'm going to have a 6x plus an 8, which is less than a 2. I'm going to subtract an 8 here. So I'm going to have a 6x is less than a negative 6. Divide both sides by 6. So x is going to be less than a negative 1. So less than a negative 1. So at negative 1 we'll have an open circle, everything to the left. So it'll be from negative infinity, parentheses, up to a negative 1, parentheses. Okay? I hope that's better. Those are just some basic regular inequalities, but they're multi-step where you have to get the x by itself, and you need to move the x on to that left side. Okay, so these two, though, are compound. So compound or means that I'm going to take that one inequality, solve it, going to solve that second inequality, and we're going to separate it, and it's still going to have that or on it as well. Okay, So we are going to solve this one. So we're going to subtract 7 on both sides. So x will be less than or equal to a negative 5. First thing I need to do here is to multiply by 3. So when I multiply by 3, I'll have x plus 17 is greater than or equal to a 15. I'll subtract a 17, so x is going to be greater than or equal to a negative 2. Okay, so x is everything less than negative 5 or greater than negative 2. So if I had negative 2, negative 3, negative 4, negative 5, at negative 5 we'll have a closed circle, everything to the left. And at negative 2, we'll also have a closed circle and everything to the right. So in the right, you're going in the positive infinity, and to the left, you're going into the negative infinity. So this will be from negative infinity to negative 5 with the bracket, or negative 2 to infinity. Remember, infinities always have parentheses. Okay? Alright, so this is a compound and. We have everything, we have 2, it's a compound, it's bounded. What that really means, it's bounded in between these two numbers. So I want to get the x by itself in the middle. So to get the x by itself, I'm going to subtract a 1. But I can't just do it there, I need to also do it over on that left side. So 3 minus 1 is a 2. And then 13 minus 1 is a 12. Divide both sides by 2. So we'll have 1 is less than x, which is less than a 6. So that means that x is going to be between 1 and 6. So it's going to be all the values in between there. So my interval notation will be in between 1 and 6. Okay? All right. So, absolute value inequalities. So this is the last thing that we'll cover tomorrow. We will review all of that again, so all the inequalities again, and then we'll have a quiz on Thursday on all the inequalities. So, absolute value inequalities. We're going to have 2 sets, 2 different ways to solve an absolute value. Okay? So always the first thing that we want to do is get the absolute value by itself, okay? So the first thing, no matter what, I need to get the absolute value by itself, okay? So get absolute, just like when we were doing an equation. So get the absolute value expression by itself on the left. Okay, so get it by itself on the left. Okay, so then the second thing is you're going to look at the inequality sign. Okay, so look at inequality sign. Okay, when you look at that inequality sign, that's going to tell you what you're going to do. Okay, so if you have absolute value of x is greater than some number c, I'm just making this up here. So if you had the greater than, okay, so greater than means I'm going to remove my absolute value. Greater means I am going to have an or inequality. Okay, so if you remember, they go that directions, those are going out. Remember the ors, they go out. So I'm going to remove my absolute value and I'm going to have x is greater than that c, or over here then I'm going to have x would be less than, so go to the left, less than, and I'm going to change this instead of being a positive c, I'm going to change it to a negative c. Okay? So I'm going to have 2 inequalities. So if I have a less than, or a greater than, if I have a greater than, you hear how I'm saying that? Greater. If you have a greater than sign there, you're going to have two inequalities. Okay, if you had a less than, okay, so less than is going to be in between. So it's going to be the compound and. It's going to be the compound and where you're getting everything by itself in the middle. So here, you're going to have x is less than a c. And over here, you're going to have x is greater than a negative c. Okay, so those are your two cases. You could also have it where it's greater than or equal to, then these would just be greater than or equal to, less than or equal to. If this was a less than or equal to, the equal to sign would just go underneath there. Okay, so look at the inequality sign. So here's your one case, here's your second case. Then you'll solve and graph. Okay. All right, so let's think about this. So you know now the rules. So here I want to have absolute value of x is less than 5. Okay, so absolute value of x is less than 5. Is my absolute value expression by itself? It is. And what is my sign here? That is a less than. So less than means and. Okay, so what we're going to do is we're going to say x is less than 5. So I'm removing the absolute values and I'm going to have x is less than 5. And also over here I'm still going to have a less than, but I'm going to change it to a negative 5. So it's going to be in between those two values. I don't have to do any solving, so now I can graph this. So at negative 5 we'll have an open circle. At a positive 5, an open circle, and it's everything in between here. So it'll be everything in between negative 5 and a positive 5. Good. What about this one, number 2? Absolute value of x is greater than or equal to 4. Absolute value is by itself. This is a greater. Okay, so greater means we're going to have an or. Okay, I'm going to remove my absolute value, so I'm going to have x is greater than or equal to a positive 4. So I'm just going to have that identical thing, just like I had that identical thing over here. But over on the left side, it's going to be x. I'm going to change it instead of being a greater than because I need to go in opposite directions, right? I need to go in opposite directions. So I need to now go less than or equal to. And I can't be at the same number, so I need to change it to a negative 4. I don't have to solve anything here. So now we'll have at negative 4 and we'll have a positive 4. At negative 4 we'll have a closed circle. X is less than, so it's everything to the left. X is greater than or equal to 4, so it's everything to the right. So it'll be from negative infinity to negative 4. The bracket, or 4 to infinity. Okay. Right. This one is the expression by itself. Is the absolute value expression by itself? It is. Okay. So now what type of inequality sign is that? That is a greater than sign, right? So when that is a greater than sign, we have a or. So if you remove the absolute value, we'll have x minus 1 is greater than 6, or x minus 1 is, now it's got to go in the opposite direction. So instead of being greater than, I need to be less than, and I need to be at the opposite sign, so it'll be a negative 6. So this one I do have to solve, right? So here I will add 1 to both sides. So here I'll get x is less than a negative 5. I'll still add 1 to both sides. And you'll get x is greater than a 7. So negative 5, an open circle, and it's everything less than negative 5. At 7, open circle, everything greater than. That's 7. So it'll be from negative infinity to negative 5, or 7 to infinity. Okay? All right, y'all try to do number 4 for me. So y'all try to think about this one for me for a minute. Okay, absolute values by itself. This is a less than. So less than means and. So that means I'm going to remove my absolute value. So I'll have x plus 2 is less than or equal to a 7. And then on the other side of that, I would have greater than or equal to a negative 7. So it's going to be bounded in between the negative and the positive version. So I need to now get the x by itself in the middle. Right? But I can't just do it there. I need to do it what? Over on the other side too. So we'll have a negative 9 is less than or equal to an x, which is less than or equal to a 5. So we have a negative 9 and a 5. Close circle at negative 9, close circle at 5, and everything in between. So everything in between negative 9 and a 5. Okay? All right, so y'all do this one for me. Okay, so number 5, that one, the first step would be to do what? The absolute value expression is not by itself. So the first thing I need to do is add 1 to both sides. So I'm going to have the absolute value of x plus 3 is less than a 6. Okay, so now I can do some manipulating. So it's x, absolute value of x plus 3 is what? Less than. So that less than, the less than means what? The and. Okay, so you're going to remove that absolute value. So you're going to have x plus 3 is less than 6. Less than negative 6 over here. So get the x by itself in the middle. So we'll subtract 3 on all sides. So we'll have a negative 9 is less than x, which is less than a 3. So negative 9, open circle, 3, open circle, everything in between. So negative 9 to 3. Okay. All right, what about this 6th one right here? That's 3 times the absolute value of 2x plus 8. The absolute value expression is not by itself, so I need to get it by itself. So the first thing I would have to do is to do what? Divide both sides by 3. So then you'd be left with absolute value of 2x plus an 8 is greater than or equal to a 10. That says greater than, so greater, oops, or greater than sign, so that's not or. Okay, so if it's an or there, then it's going to be 2x plus an 8 is greater than or equal to a 10. And over here, it'll be 2x plus an 8 is, instead of greater than, it's going the opposite direction because we want them to go out in the opposite ways. So they're going in the opposite directions there. And then this one will be a negative 10. Okay, so we'll solve each one separately. So a negative 8, subtract your 8. So we'll have 2x is less than or equal to a negative 18. Divide both sides by 2. So x will be less than or equal to a negative 9. Over here, same thing, subtract 8. So you'll get a 2x is greater than or equal to a positive 2. divide both sides by 2, so x will be greater than a 1. So we're going in opposite direction, so we got our -9 and a 1. Close circle, x is less than or equal to -9. X is greater than or equal to a 1. So this will be -infinity to -9, bracket, or 1 to infinity, bracket around your 1. Okay? Alright, y'all try to do 7 and 8 for me now. So we have to get the absolute value expression by itself first in both of those. So y'all try to do this. Okay? 7's kind of tricky. So, 7, first thing I need to do is multiply both sides by a -2. So, if I multiply by that -2, I'll have the absolute value of 4x minus 8. When I multiply by that -2, when I multiply by a negative, it's going to change that to a greater than or equal to. Okay? And -6 times a -2 is a positive 12. Okay, did y'all catch that when you did that? Because remember, when you divide or multiply by a negative, it changes the way of direction of that inequality. Okay, so now it's a greater than sign. So greater means or, right? So that means I'm going to have two inequalities, right? So I'm going to remove my absolute value, and I'm going to have 4x minus 8 is greater than or equal to 12, right? And then the opposite direction will be the less than, right? So that thing, 4x minus 8 is less than or equal to a negative 12. Okay, so add 8 on both sides here, so we'll get a 4x is less than or equal to negative 12 plus an 8. Negative 12 plus an 8, which is what? Negative 4. Divide both sides by a 4. So that is a x is less than or equal to a negative 1. Alright, over here, same thing. We'll add 8 on both sides. So we'll get 4x is greater than or equal to a 20. Divide both sides by a 4. So x is going to be greater than or equal to a 5. Right? They're going in opposite directions. Okay? So, negative 1, positive 5. Negative 1, so x is less than or equal to negative 1, so everything to the left. X is greater than or equal to 5, so everything to the right. So negative infinity to negative 1. And then, or 5 to infinity. Oops, I'm sorry. Good? Alright, so what about this one? Number 8. So number 8 had a few steps to get the absolute value by itself. First thing, add 3 to both sides. Add 3 to both sides, so you're going to get 10 times the absolute value of x minus 4, which is greater than a 50. That 10 is on the outside, so we're going to divide both sides by 10. So greater than, so absolute value of x minus 4 is greater than a 5. So greater means it's going to be another or, right? So x minus 4 is greater than 5, or x minus 4 is less than a, now change it to a negative. Okay, so I'll solve both of those. So add 4 to both sides here. Really, just go ahead and do it to both of those. So x is going to be less than a negative 1, or x is going to be greater than a 9. So at negative 1, you'll have an open circle, everything to the left. And x is greater than 9, so everything to the right. So this will be negative infinity to negative 1, or 9 to infinity. Okay? All right. So absolute values, just take the rules of compound inequalities. So what we did in that last section just takes all of those rules and applies it to that. So just make sure that you can solve compound inequalities, because if you can't solve compound inequalities, you cannot solve absolute value inequalities. So absolute value, get the absolute value by itself. So get the expression by itself, and then you look at the inequality sign. If it's greater than, then it's going to be an or. If it's a less than or equal to, then it's going to be a compound and, where it's in between. So, if you have any questions, please let me know.